Welcome back, learners. We were discussing about the modeling of the given residential building in the ETABS software, and in the previous lecture we were discussing about how to define the section properties. I just gave you a small example that how to define the section properties in the ETABS software. Now today in this lecture, I will explain you on what basis we are supposed to select the dimensions of the given beams and columns. Now, you know that this is the plan of the building that we have taken for the first project we have considered. Now, I already told you before we start the first analysis, we will not be knowing the exact beam dimension and column dimension. But in order to model and in order to analyze it, we are supposed to consider some preliminary dimensions of the beams and columns. Right? When we are considering the preliminary dimension, it should not be in such a way that it is too odd. That means we are not supposed to consider a very small dimensions of the beam and columns which will easily fail in the analysis, or even we are not supposed to consider a very large dimensions of the beams and columns which is very uneconomical section. Then you may have the question that on what basis we are supposed to find the beams dimension as well as the column dimension. But I will make you very clear that whatever these dimensions we are considering, it is not the final dimension, it is a preliminary dimension. This dimension will definitely may be altered once the preliminary analysis is done. Okay, so now usually what is the condition that we are supposed to consider that in order to find out the dimensions of the beams and columns? Now first let us find out on what basis we are supposed to find out the dimensions of the columns. Okay, now the first point that I would like to make very clear that whenever we are finding out the preliminary dimensions, we are not supposed to consider only one beam and column dimensions. We are not supposed to consider only one beam and column dimension. Usually we will be having 2 to 3 sets of the column dimension. Then you may have the question that why I have to consider 2 to 3 sets of the column dimension. Usually students, in some areas of your plan, the load coming on the column may be very small, where providing a very large section there will be uneconomical. Similarly, in some part of your plan, the load coming on the column may be very high, where providing a very small section leads to the failure. Right? So in some other parts, there may be an intermediate loading coming, where providing a small section leads to the failure, whereas providing a large section leads to uneconomical. In such case, we are supposed to go for the intermediate dimension. So therefore, in order to have all kinds of possibilities, usually we consider 2 to 3 sets of the column dimensions. Okay, 2 to 3 sets of column dimension. Sometimes the architect itself may give you those dimensions. If not, it is our duty as an engineer to decide the preliminary as well as the final dimensions of the column. Okay, now that is the basic condition that we have to see. Now before I move on, that what is the basic concept that we have to keep it in mind while choosing the dimensions is mainly it is loading. Okay, main condition for the selection or the fixing the preliminary dimension of the column is loading. Okay, now I would like to explain you one concept here, students. When we go through the IS 456 2000, in that it was very clearly written that how the distribution of the loads, will occur on the slab. For example, you have a slab like this. Okay, you have a slab like this. So when you have a slab like this, usually the distribution of the load will be like this. Okay, the distribution of the load will be like this. Okay, the distribution of the loads will be like this, what we call that as trapezoidal load. Okay, what we call that as trapezoidal load. Okay, this is the usual distribution of the loads in the slabs. Okay, it means the loads of this area will be transferred to this beam. The loads of this area will be transferred to this beam, whereas the loads of this area will be transferred to this beam, whereas loads of this area will be transferred to this beam, and loads of this area will be transferred to this beam. This is what we call it as the trapezoidal method of transferring the loads. Okay, so this area load to this beam, this area load to this beam, this area load to this beam, and this area load to this beam. Okay, now according to this case, by considering that condition, usually we have to see that if I consider a particular column, usually how many number of beams are going to rest on that column, and usually what is the approximate area that the column is going to have. For example, let us take this first floor plan. Now just see a student, let us consider this column. Okay, I don't know the dimension of the column, let us consider this column. When I consider this column, you can clearly note that there is a beam which is coming here, and there is a beam which is coming here, and there is a beam coming here. Now if you see, when a beam is going to be connected between the two columns, we are going to call that as the mother beam or the primary beam. For example, if you see this beam, this we are going to call it as a mother beam or a primary beam, because this beam is connected between two columns. This beam also we are going to consider this as a mother beam or the primary beam, because it is also connected between the column. Whereas this beam is also, we are going to connect it as a mother beam or a primary beam. Even this beam is also mother beam or primary beam. So means whenever a beam is connected between the two columns, then they are the primary beams or the mother beam. Whereas when a beam rests on the another beam, or one side of the beam rests on the column and another side of the beam rests on another beam, then we call that as the secondary beam. For example, if I consider this, you can see here this beam is resting on the pillar or the column on one side, and on the another beam, that is this beam, on the another side. Such kind of beams, even this beam, those beams we are going to call it as the secondary beams, right? One more practical point that you should keep it in mind, student. Always the depth of your primary beam or the mother beam should be greater than or equal to the depth of your secondary beam. You cannot place any secondary beam whose depth is larger than that of the depth of the primary beam. For example, if I am considering this beam is having a depth of 500 mm, then the depth of this beam should be equal to 500 mm or it should be less than 500 mm. It cannot be lower than 500 mm. Okay, so if you are doing like that, then definitely the beam is going to fail. Okay, because you know it is a secondary beam which is not resting, because all the loads whatever this beam receives, half of the load will be transferred to the column, whereas another half of the load will be transferred to this main beam. From this main beam it will be transferred to the columns. Therefore, this main beam or the primary beam should be strong enough to receive the loads from this beam. Therefore, its depth should be greater or at least equal to that of the secondary beam. It should not be less than that of the secondary beam. Okay, that is one point. And now I told you on what basis we can able to justify that column is going to receive more loads. Now, if I take this column C1, you can see a student that it is going to receive three beams, this one and this one, out of which this is a main beam, this is a main beam, and you know this is a cantilever projection. It means whatever the beam that this column is having, both are main beams. It means it is going to receive a very little bit of large load itself. And not only that, you can see here this entire slab load whatever is there, that will be transferred to these columns, and finally again that will come to this column only. Finally again that will come to this column. Whereas here if I consider this slab, so then half of the load will come to this beam and from this beam to this column, and then remaining keel will come to this column. It means I can say that this beam receives a quite heavy loading. Okay, even this also it may receive quite heavy loading. Okay, now even this also it is going to receive very quite high loading, because this entire area whatever is there, that will be distributed to this column, this column, this column, as well as this column. And here this entire load will be load on the slab will be transferred to this column, this column, this column, this column. Okay, so usually even that is also little quite high. So therefore what we will do, we will just make a column changes, color changes we will do. So what I will do, I'll just make it as this color. Okay, yeah. So what I'll do, I'll just connect, I'll select this and I'll make that as this color. Okay, or we will do one thing, we will make some other color. Yeah, I'll make it as red. Okay, the same. So even this beam also going to receive a quite high load. Even this beam also, this column also, as well as this column also. So therefore, let us make this four columns of one particular dimension. Okay. Now, so whatever the columns that I am showing in red color will be of very high load, whereas the one which is in the yellow color, it will be of the medium load, whereas the one with the green color will be of the less load. So like that we will make bifurcation: red high load, yellow medium load, green low load. Right, so since these four receives a little bit higher load, I am making the columns red. Now even this columns also receives very higher load, because you know everything here is cantilever. So therefore even this load, okay, even this column also I'll make it as red. Okay, even this column also I'll make it as red. This column also I'll make it as red. Now if I come here, you can see that the three columns are very close to each other, and even this area whatever you calculate, so here you have already have a very two high columns. Okay, so since you have a very two high columns, we can make that that these three columns may be of the medium load. Okay, so this I will make it as red only because this entire area load has to come here. So therefore let us make that this as a heavy column only. Okay, this as an heavy column, this as an heavy column, whereas these three columns I can make it as a medium columns. Okay, these three columns I can make it as a medium columns, right? Therefore I'll just select this and I'll make them as yellow. Okay, I'll make them as yellow. Yeah, right. So similarly, even this and these two columns I can make it as same yellow because they are very close also. Okay, I can make them as yellow. This one, this one. Okay, now I'm just explaining you about how to decide that whether the column receives is a heavy load or it receives a medium load or it is a lower load. Keep it in mind, I'm not explaining you about the orientations, so that we will take up in the next lecture. Okay, not in this session, we will take up in next lecture. Now again if I take this, now you can see a student that three columns are there, but if you see next to that you have a very large beam whose length is almost 20 feet. Okay, so definitely this column will receive a very high loading. At any cost we cannot make this as a medium, so better we will have a high columns only, these three columns as well as these three columns. Or what we can do, these four columns we will make it as high columns, whereas these two columns we can make it as a medium load columns. Therefore what I will do, so I will just match this one with this as well as with this. Okay, whereas I will match the high load columns, this one with this, with this, with this and this with this, because it is very clearly evident that you have a very high beam of 20 feet, so therefore we cannot make them small. Okay, so now again if I see this, now you can see this student that these four columns I can make it as a low columns. Okay, these four columns I can make it as a low load columns. Okay, so I can make it as a low load columns. The reason is you can see here that the area is also very small. Okay, so these four columns I can make it as a low load columns, therefore I will keep it as green. Whereas this and this column, so let us make it as the medium, because you can see here that staircase is present here. Since the staircase is there, so we cannot avoid them. So therefore what we will do, these two we will make it as a low load column, whereas these two and these two we will make it as a high column, and these two we will make it as a medium column. So therefore what I will do, I will choose match properties. I'll go here. So this column I will make it as high, 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 whereas this and this let us keep it as a low column. Okay, so like this, based on the number of beams that a column is going to receive, and based on the area of the loading that a given column receives from the slab, so we have to decide whether it is a high load column or a medium load column or a low load column. So once we categorize them into those three different column loadings, then now let us assume the preliminary dimensions of the columns. Let us assume the preliminary dimension of the column. Now, while deciding the preliminary dimension of the column, the two concepts that we have to keep it in mind: what should be the shape of the column, whether it is a rectangle or a triangle or a square or any other shape, and what should be the dimension. So these two things we have to keep it in mind. The orientations of the column I will explain you when I am going to do the modeling in the software. So before we start the modeling, so I would like to explain you about the importance of the shape of the column and the dimensions of the column. After that, we have to understand how to decide the preliminary dimensions of the B. So these three concepts I'll explain you in the next lecturing video. Once this is decided, then in the ETABS we will define them and then we will start modeling. Okay, I hope you clear everything in this session. Thank you, learners. We will continue in the next video.